Munich, and he's teaching software development there. And I know Axel very well. He's always on the search of the leading technologies. That's the reason why he's jumped into Node. And he does many student projects, and he's always trying to apply the latest technologies and techniques like agile software development or Git, all those things that you typically don't see in the university setups, but not so with Axel. And he was so nice to offer on our Oktoberfest visit. Before he left, I said, hey, come on, give us a lightning talk on our next meetup. So always be prepared to don't make contract negotiations after the Oktoberfest. So now he's here. So give him a warm welcome.
Thank you very much. I promised on the Oktoberfest, but I will remember the next day that I promised it. I tried to bring together leading edge technology with older technology. I'm talking on time critical hardware control with Node.js. And I will tell you something about pinball machines first, and why we tried and how we tried to get a new control software for an existing, some, I don't know, 13, 14 years old pinball machine. So the idea is we had this old pinball machine built 15 years ago with control realized on Pentium 2 or something really outdated today, and when the computer that is built in dies, you really do not get spare parts. So this machine was left over, and we tried to implement a new control for this machine. So I hope every one of you knows what a pinball machine is.
Star Wars.
When?
Star Wars.
So we can either write new software for the existing machine, or we could also try to build a new machine completely up from scratch. But that's more complicated than using an existing machine. Why would we do it? Well, just for fun. So that's something we can do at the university, or we can use it as a demonstrator. We had a prior solution based on real-time Java, where we had a lot of configuration issues and testing issues. So we were not really lucky with that solution. And the first time I saw Node.js, I thought, oh yeah, that could be a good idea to use Node.js. From its event processing type of nature, it seems naturally useful for this control purposes. And it seemed an alternative. So the main thing is you have to react to switches and timers when you control a pinball machine. At the heart you have this driver board. This is essential high power electronics to drive lamps and to drive coils, solenoids, really with high voltage and high currency. You see the connectors for lots of cables down here, and on the other side you see a parallel interface. And this parallel interface controls mainly three things. The first thing are switches, and switches are organized in a matrix of 8 times 8. That's just to reduce the number of miles of wires you need to wire the machine. So if you have 64 switches on your machine, you don't need 64 cables or 128, 2 cables per switch, but you can reduce it to 16 cables plus 2 for the return. And you continually have to question this matrix row by row. The same organization holds for lamps. We have 2 matrices of lamps, and we can control these lamps row by row. So you have to pulse this, and pulse every lamp column, and on the other side you have to feed registers with the information which lamp has to be on in that moment where you switch on this row. So the wiring is quite interesting. It's something like that. So you have two times 8 cables to the board, and you feed 64 lamps with that, and the same goes for the switches. Now we come to the part with what problems did we have to solve. One thing is we have to scan all the switches at least every 1.5 milliseconds, and that's a design from the hardware board. If you do not read the switches every 1.5 milliseconds, there is a watchdog timer, and that closes a relay and shuts down the complete game. The next thing is you must react fast to switches, otherwise it is not fun to play the game. So if you are playing the game, if you ever have played a pinball machine, you might have seen that it only is fun if the software really reacts very fast when you hit the target, so when you close a switch or when a timer times out, also reaction has to be instantaneously. The next thing is when the solenoids fire, you have really a wired solenoid. This consumes a lot of currency. When this is switched on for too long time, it will just burn. And you have a really expensive coil burning down. This must be prevented anyhow. And the third thing is the lamps are pulsed. So you have lamps with a voltage designed some 6 volts, and current voltage you use is 18 volts, and you have to pulse them by at least 1/3 of the time. So if the pulsing stops, also one row of lamps will burn through immediately. So a programming mistake can become quite expensive. We had this one time where we had timing issues and something burned, and it's all really defective hardware you have done. The question is, can we do it with Node? And a guy who also worked sometimes with TNG, Wolfgang Hackenberg, he did his bachelor thesis on this, and that's actually the content of his bachelor thesis I'm talking about here, so it's not really my own work. But he didn't want to come, or he could not come here, so I tried to summarize his results. What were his tasks? Get control over the parallel port, so the board is controlled by a parallel port. Implement some reasonable timers and analyze if the garbage collector can make problems in these timing issues. And so he should define a reasonable architecture, and we should see where the boundary between C++ code on the parallel port side and JavaScript should be. The first thing he solved was the access to the parallel port. We used the Linux operating system, and he modified the parport package, which is available as a Node package. He had to do some modifications because this did not really support the fast switching between reading and writing to the parallel port. So the parallel port is used really bidirectional here, and that was not supported by this library. And he achieved 150 read-write cycles per millisecond. So that's very good and sufficient for our timing constraints. The next thing were the implementation of timers. He found out that Node's built-in set timeout and set interval functions do not really work as desired. They are limited to a minimum of 1 millisecond. And he used a high resolution HR time, which is also a quite new feature in Node. And he used some kind of active waiting or spinning. Well, active waiting is not always a good idea, but it's kind of the idea of the spin locks Windows uses nowadays, Windows can use nowadays. So what he did was to use the HR time function, which gives the timing information, and he loops events through the event queue until the desired time has come. That's essentially what this code does. So if the time has not come, you just insert the event again into the queue, and when the time has come, you call the callback and execute the code that has to be executed when the timer times out. The next thing, which is still an issue, is the garbage collector. The question is, what happens if the garbage collector interrupts our control software? And there, well, some hope comes into play. We assume that several recent and ongoing improvements help. The V8 guys did quite a good job. They built an incremental garbage collector, and they do a garbage collection of 1 millisecond per megabyte currently, and this helps. So up to now we didn't see any problems with the garbage collector. Also, we use some techniques to use sparingly the available memory, something like object reuse and all these techniques, you might know from small memory systems. But we might possibly use some workarounds. The first thing is, sometimes we have a pause during gameplay when the ball is held in a lock and waiting for some user interaction. We could intentionally start the garbage collector and say, okay, now is the point to wait several milliseconds, which won't hurt the user. And on the other hand, we could also move the communication between Node.js and the parallel port some more to the C++ side. So currently what we do is that most of the work is done in JavaScript, especially the periodic scanning of this parallel port, of the power driver port. And what we could do is we could move the scanning of the port to C++ and let the C++ code insert events into the node queuing. But currently we have most of the work done in JavaScript. Well, that's a rough view of his architecture. We inserted a layer that abstracts the hardware, something like a hardware abstraction layer, which you also could see as the model in some model view controller paradigm. It holds all the information of the pinball machine, and on top of that we implemented a state machine. And the advantage to the prior real-time Java implementation is that this is much more easily configurable. You can use JavaScript objects directly in the configuration. And when we did it in Java, we had a lot of reflection code, which we didn't really like. So to come to an end, the problems could be solved. Well, okay, solved if you count crossing fingers as solution. But the garbage collector issues are not finally resolved. But up to now we didn't see any problems with that. We have a flexible architecture, and I hope that I will find another bachelor student to implement a rule set. And the configuration has really been improved in comparison to Java. And when we can do the configuration in JavaScript, we have all the JavaScript toolset. So you write your configuration in JavaScript, and you have your IDE-based refactoring if you want to refactor your configuration. That's a really good idea. Okay, so thank you for your questions. So I wanted to bring the machine with me.
Short question maybe. I do not know a lot about hardware, but the name parallel port makes me think that stuff happens in parallel. And if two events come at the same time,
it's just no.
Node.js serialize that?
That's much more primitive. That's the old, what's that, IEEE 1994. 1394, okay. The old printer interface. Just means that you can transfer 8-bit in parallel, I think. So it's 1 byte or is it 5 bits? Yeah.
Okay.
So to transfer some bits at the same time. Well, it's in contrast to the serial V24 interface. That's really old technique, but really old technology. But this control board uses this interface anyhow. So there's no choice.
Yeah, so you're close to found your pinball repair startup.
That's, well, something you do not really like to earn money with.
Most actually casino machines work exactly like
Yes,
current
most of
machines.
them. Yes, yes.
It's not old technology for
Yeah,
point of
current
view
machines.
games.
Yeah, still work.
So,
Okay.
thank you.